Today, we're diving into solving exponential equations with a common base. If we have an exponential equation a raised to the power x, and it is equal to the same base a raised to the power y, then x has to be equal to y. For example, if 5 raised to the power x is equal to 5 raised to the second power, then for both sides to be equal to each other, x has to be equal to 2. So generally speaking, if the base on both sides is the same, then we can ignore the base and equate the exponents to each other. And so we get x equals 2. Now let's try a few problems. Solve the equation shown here. At first glance, the bases on both sides are different, and so the aim is to rewrite one of them so that we can have a common base. We usually go for the smaller base, which is 4. So to write 64 with base 4, we think of the power that we can raise, 4 to get 64. That's 3. So we rewrite 64 as 4 to the third power. Now that we have a common base, we can drop the base on both sides of the equation and equate the exponents to get x equals 3. Here is another problem. Again, the aim is to rewrite one of them so that we can have a common base. The smaller base is 2, and so we need to rewrite 32 with base 2. Now 32 is the same as 2 to the 5th power. However, the base needs to be in the numerator, so we apply a law in indices and flip the base to the top. But remember, you need to change the sign of the power from 5 to -5. Now that we have a common base, we can drop the base on both sides of the equation and equate the exponents to get x equals -5. Let's try another problem. Before we try to rewrite the bases in any problem, we need to ensure that we group all the constants. Therefore, we can group -12 on the right with 500. And so we get 500 plus 12 on the right-hand side of the equation, which is 512. We can now rewrite one of the bases so that we have a common base. The smaller base is 8, and so we need to rewrite 512 with base 8. Now 512 is the same as 8 to the third power. Now that we have a common base, we can now drop the base on both sides of the equation and equate the exponents to get 3x minus 9 equals 3. To solve, we group 9 on the right to get 3x equals 12. Divide both sides by 3 to get x equals 4. In this example, the smallest base is 3, so we need to rewrite all the terms using base 3. However, the number 10 cannot be written in base 3, and so we can divide both sides of the equation by 10 to get rid of the 10. And so we end up with 3 raised to the power x minus 2 equals 243. Now 243 is the same as 3 raised to the 5th power. Now that the base on both sides is the same, we can drop the bases and set the exponents equal to get x minus 2 equals 5. Solve for x. Hence our solution is x equals 7. The last example is the most fun. One approach is to get rid of the fraction first by multiplying both sides by the denominator. So we multiply both sides by 3 to the power 2, x minus 1, which eliminates the denominator on the left. We have 4 different bases, 9, 27, 81, and 3. And so the aim is to rewrite them all to a common base. The smallest base is 3, so we'll rewrite all of them using base 3. Now 9 is 3 squared, 27 is 3 cubed, 81 is 3 to the 4th power, and the final term is already base 3. So now we multiply the power outside the brackets by the power inside. For the first term, we get 2x plus 2. In the second term, we get 3x plus 9. For the third term, we get 4x plus 4. The final term is the same, 2x minus 1. Now, the law of exponents states that when multiplying two terms with the same base, we add the powers. The base is the same 3 on both sides, so we add the powers on the left and then do the same on the right. On the left, we group the like terms to get 5x plus 11, and on the right, we group the like terms to get 6x plus 3. Now that we have a single base on the left and a single base on the right that are both the same, we can drop the bases and equate the exponents to get 5x plus 11 equals 6x plus 3. Solve the equation by grouping the terms in x on the right and the constants on the left to get our final solution, x equals 8. So today we learned an extremely useful rule for solving exponential equations. Step 1. Rewrite both sides so they have the same base. Step 2. Drop the bases and set the exponents equal. Step 3. Solve the resulting equation. This method works beautifully whenever the bases can be rewritten to a common base. Be sure to like, subscribe, and share Adobe Math Lab with a friend who needs help in math. And stick around for the next video where we'll look at exponential equations that don't have the same base and see how logarithms come to the rescue. See you soon.